Hello and welcome to the lecture on Lighthouse Project at Rajkot. My name is Shailesh Agarwal, Executive Director, Building Materials and Technology Promotion Council under Ministry of Housing and Urban Affairs. And I'm going to educate you all through this presentation about the field level implementation of innovative construction system being used in this LHP, including design basis, materials, manufacturing, structural drawings and detailing, and actual site photographs explaining the different construction stages. The outline of my lecture is as follows, starting from Global Housing Technology Challenge India and Lighthouse projects, the technology in terms of various structural elements, namely foundation, structural system, block masonry, followed by design basis, will be explained, followed by construction activities at site. Ministry of Housing and Urban Affairs, Government of India organized Global Housing Technology Challenge India in 2019 to evaluate, assess, and shortlist proven demonstrable construction system across the globe, which can help build houses at a faster rate in minimum time and at minimum cost without sacrificing structural and functional performance. Based on the Global Housing Technology Challenge, 54 new construction systems have been identified, and they are broadly classified into these 6 categories. Today, we are going to discuss monolithic concrete construction, in which 9 technologies have been identified. Before getting into the details of Lighthouse project at Rajkot, there are 6 projects which are currently being executed at these 6 locations, namely Chennai, Indore, Ranchi, Agartala, and Lucknow, using the 6 broad categories which I showed you in the previous slide. Today, we are going to discuss monolithic concrete construction using tunnel formwork, which is the technology being used in Rajkot. If you want to know about the project brief, there are 1,144 houses are being constructed in a configuration of steel plus 13, that is 14 story. The total plot area is 39,600 square meter, and the carpet area of each house is 39.77 square meter. There are 11 residential blocks which are distributed like this on a layout. If you want to see the typical floor plan, so this is a typical floor plan, and at each floor there are 8 dwelling units, 1, 2, 3, 4, 5, 6, 7, 8. In addition to the housing, the project also include basic physical infrastructure as well as social infrastructure. This shows the typical dwelling unit plan, which comprises of 2 rooms. One is bedroom, another one is living room, along with kitchen and bath and toilet. Here, a provision of a study room is also being given. The carpet area for the Rajkot is 39.77 square meter, which is higher than the carpet area being used by other states. In addition to the housing and social and physical infrastructure, the other special features which are included in the project are green rating as per GRIHA. Minimum rating of 3 needs to be achieved for the project. Then use of renewable resources are being promoted in terms of rainwater harvesting and solar lighting. Solid waste management system and sewage treatment plant with recycling of wastewater is also added in the project. Now let me explain you the technology which is being used in the Lighthouse project at Rajkot. If you look at the prevalent construction practices which are in vogue, they are shown on the left-hand side. Primarily, when we construct low-rise structures, we normally made them with brick and mortar. We construct the house by laying bricks wall by wall with mortar, and then lay the slab cast in situ. The other prevalent construction when we go to high-rise and to cities is cast in situ RCC frame construction, where RCC columns and beams are cast at the site, and then cast in situ slab is laid along with reinforcement. And later, the walls, which are called infill walls, are constructed with brick masonry or any other block masonry. In this picture, what you see is fly ash bricks being used. So these are two prevalent construction systems, and as all of us know, these prevalent construction systems are not sustainable because they attract time overruns, cost overrun. There is a lot of pollution, wastage of material. So we need to have a technology which is resource efficient, fast track, at the same time sustainable. So in Rajkot, we are using monolithic concrete construction using tunnel form. I will explain you why it is called monolithic concrete construction. But here we are using a tunnel formwork. Normally, in a typical conventional construction, when a slab or a column is being cast, normally we put the shuttering, which is known as the formwork. It is a kind of mold in which reinforcement cage is laid and then concreting is done. Then once the concrete attains its strength, then the formwork is removed. Here in this system, what we are doing is, as per our project requirement, the formwork in form of a tunnel, and you can see this is a L kind of formwork. So these are two L's which are tailor-made for the project which is being done. So these tunnel forms are being manufactured in the factory depending upon the project requirement and as per the project layout. So this acts as a formwork, and at the site, once the tunnel formwork is installed, then concrete is poured for the walls and slab together after laying the reinforcement cage. So this concreting being done in a single pour after the reinforcement creates a monolithic tunnel kind of structure, and that is why it is called monolithic concrete construction. Now, instead of having formwork for column, beam, and slab separately, the entire dwelling unit comprising of wall and slab is cast together, giving this technology an edge and enabling faster construction. Also, there are no joints because everything is being cast together. And this formwork, if we use concrete with plasticizers and admixtures to get early strength, this can be removed within 1 to 2 days and then shifted and installed on the next floor, and the casting is done on the next floor. That way, in a single day, you can cast a floor. So normally, if you look at the cycle, first what is being done? First, reinforcement cage is being laid. After that, these L's are being placed on the outer as well as on inner side. Once these are placed, then concreting is being done. Then reinforcement on slab is also being placed, and then concreting is being done. And once concreting is done, then after 1 or 2 days, you remove this formwork and shift it to the next floor. And that way you construct this kind of structure. And why it is called tunnel form? Because through this tunnel formwork, you are able to create these kind of tunnels. And once these tunnels are made, the skeleton of the structure is done, and then this spaces can be filled with infill walls, and that can be of masonry. Here, the AAC masonry is being used. AAC is aerated, autoclaved, aerated concrete blocks. Okay, so the typical cast in place RCC framed structure using formwork is replaced by customized tunnel formwork, and the entire dwelling unit is being cast together in a single pour. Also, this kind of construction is known as shear wall construction, because walls and slabs cast together, these walls are reinforced concrete walls and act as shear walls. So it is very excellent as far as disaster resilience is concerned. For earthquake, this is an excellent system. Also, let me add here that monolithic concrete construction using tunnel formwork and using aluminum formwork is the most popular and technology in India, and several thousand of houses at present are being constructed not only under Pradhan Mantri Awas Yojana but also in several schemes and being used by public and private players in the residential as well as in infrastructure sector. Now, let me briefly tell you about the structural elements. So, structural elements primarily comprise of substructure and superstructure. Substructure is nothing but foundation, and substructure comprise of your beam column, or in this case, this is a monolithic shear wall along with slab. So, and then this space, as I told you, is AAC block masonry. So I will explain you all these three things one by one. As regards foundation, a conventional foundation is being proposed in this lighthouse project at Rajkot, because as per the geotechnical investigation, bearing capacity, soil strata, and water table, you can decide upon the foundation. So here, typical raft foundation of varying sizes is being used, and what you see in this picture is this raft. And once you lay this raft over this, you put stem columns up to the plinth, and after the plinth, you start erecting the tunnel form and then do the slab and shear wall together. Now, you can see in this, once you have laid the PCC over that, you put the reinforcement cage, and once the reinforcement cage is put, you can start concreting the raft. Here, as per structural drawings, the raft is using M25 concrete. And once this raft is being done in the areas where we have lifts and all, there the thickness of raft is increased. And what you see here, this is the, after laying the raft up to the plinth level, columns, and which are also known as shear, which are also called here shear walls. Shear walls are constructed up to the plinth level. And at the plinth level, once you come to the plinth level, double bars are left, and those double bars are connected with the reinforcement of the walls on the floor, and then the tunnel form is installed, and then concreting is done. So first you do the foundation. It is a conventional raft foundation. Over the raft foundation, you erect shear walls up to the plinth level, and then once you come to the plinth level, so this slide shows you the finished, this is a plinth level, this is a raft shear wall up to plinth level, as you can see here. So this is a raft, and over that, these are these shear walls which are coming, and these will be cast like this. And once you have done the reached the plinth level, then what you do, you put this tunnel form, which is in L form, insert it on the inner side and outer side, or over the, first you lay the reinforcement cage, and then you insert this tunnel form work. So tunnel form work, as I told you earlier, it's a customized engineered form work, which is based on two half shells. Basically, these are painted steel plates, and these two half shells, when joined together, they make a room in form of a tunnel. And several cells of this kind will make the apartment. And as you can see here, they are, because these are heavy structures, so they are well supported by props, and these tunnel forms are being manufactured in the factory and then transported to the site, and then you insert them on the already erected reinforcement cage. And once this, as you can see in this slide, once you have put the tunnel form in place with the reinforcement, and then you put the reinforcement over the slab, and then you do the casting. And once you pour the concrete, which is a self-compacting concrete, after 1 to 2 days, you remove this tunnel formwork and take it to the next floor after leaving few props at the prominent locations. So that way you can construct the entire dwelling unit pretty fast. So construction sequence, if I have to tell you, it is divided into phases, and each phase consists of section of structure that will be cast in 1 day. And this phasing is also determined by the program and the amount of floor area that can be poured in 1 day. So depending upon the concreting which can be done in 1 day, the entire project is divided into phases. Reinforcement cage is laid, and once reinforcement cage is laid, then the entire concreting which can be done in 1 day is poured, and then the next day you remove the formwork and take it to the other floor. So this kind of construction gives you shear wall construction. So the structural system used here is shear wall system. Now, once you have made this shear walls along with slabs, the outer two walls are later filled. Outer two walls are later filled with aerated, autoclave aerated concrete blocks, and they are non-load bearing walls and can be used for internal as well as for these outer walls. So just to show you the assembly, it's a closure look. What you see here, this is what is being manufactured in the factory. So you get, depending upon your project site and depending upon the project requirement and the time available to complete the project, you can get 2, 3 or 4 sets as per the requirement. It is always advisable to have one spare set, because in case of any damage or in case of any malfunctioning, you can use the standby set as well. So once you have this kind of L, what you do is you create this kind of cell by joining these two L together. So what you can see here, this is how it is being inserted, and similarly from here another tunnel form will come, and before inserting this tunnel form, you have to erect the reinforcement cage for the walls, and once you have done that, then you have to do the reinforcement cage for the slab. So this is how it is being done. And then if I show you this work cycle, so you can see it is a 24-hour cycle. So what you see here is stripping. Once you have put the reinforcement and done the concreting, then what you do, you remove this formwork. So this picture shows that sliding this elf kind of tunnel form out and taking it to the next floor. So you are taking it to the next floor. Here reinforcement is erected before putting this in tunnel form, and then similarly you remove this LL and put it like this. And once you have put this, you are putting this reinforcement, and after putting this reinforcement, you do the concreting, and this is how it is being done. So you are stripping, you are sliding it here, then putting these L forms here, the inner, then you are putting the reinforcement cage, which is like this on a already left double bars from the floor below, so as to have a monolithic action. And once you have done this, then what you do, then you do the concreting of for all. So this is the reinforcement you have put. You have put this L, and after putting this reinforcement, you put the other tunnel here. And once you have put this tunnel, you do the concreting. So stripping of formwork from the previous day, positioning of formwork for the current day phase with the installation of mechanical. So all the services, when you put this formwork from inside, all the services, MEP services, plumbing, mechanical, electrical need to be put. And after that, you put the reinforcement, put the outer tunnel form, and then put the reinforcement or slab and do the concreting in a single pour. And then next day, again, you strip off this formwork and take it to the next floor. So this is again pictures from the actual site. So what is being done here? Placement of tunnel formwork for slab and wall. So this is how it is being placed, and this is how concreting is being done. So this is a typical reinforcement of a slab. Once you have put the tunnel form, you put the reinforcement for slab, and then do the concreting of slab and wall together. So giving a monolithic slab and wall system. And again, it's a closure look. As you can see, once you have, through pumps, you do the concreting. And when you are doing the concreting, after that, you level the concrete so as to get the smooth surface. So already laid reinforcement, and then concreting is being done to get the smooth slab. And once you have done this, you remove this. So this is how the structure look like. So it is as you can see, these are perfect, smoothly finished walls, and you don't require any plaster. You can just get away with the putty and just paint it, and it will be ready to use. And what you can see here, this is how it is being removed, and then it can be taken to the next floor. And in this slide, as you can see, once you have finished this floor, you have laid this reinforcement, and then you insert the tunnel form. So as I've been telling you, you can first put the reinforcement and then put the tunnel form, or you first put the tunnel form inner side and then do the reinforcement and then put the next tunnel. So either way, depending upon the site conditions and depending upon the sizes of room, you can do these things. It is also important to note here, when you are doing this wall, you need to leave few double wards, which those double wards will be connected with the reinforcement cage of this floor. And once you have done this, after this, you also put the reinforcement of slab into these walls and then do the casting. And this is being done to get monolithic behavior and to achieve structural integral action. Okay, so I hope this is clear. What we are doing here is, on an already laid cage, you are inserting tunnel form, which is customized and manufactured in the factory, and this tunnel form is made of steel. It have this formwork is customized as per your project requirement, and